Alright guys, today we're working on a 2019 Hyundai Tucson with the 2.0 GDI engine, and we've got a check engine light on this vehicle. And if we pan down to the scan tool, what we can see is it's a P030x DTC, and we're getting a rolling count of misfires on cylinder 2. That makes sense with that code. I'm not sure why the scan tool is not registering any counts on the general misfire counter, but we are getting counts on the catalyst damaging misfire and the emission relevant misfire PIDs. So I don't know if that's a software glitch or whatever, but we are at least confirming that we've got a recurring misfire, and with a recurring misfire we can diagnose it. So let's hop under the hood and I'll show you my approach for figuring out what the source of this is. Alright guys, to get at the first thing we're going to look at, we're going to take a look at the ignition coils. So we're going to need to remove this engine cover. There's 4 little prongs in each corner. It just unsnaps. These little rubber grommets hold on to these little studs. There's 2 plastic ones on the intake manifold and then 2 metal ones over here on top of the camshaft cover. And what we're after here, set this aside, is these are the coils. So from the front of the engine where you see the belt, we can count the cylinders starting at 1. So this is cylinder 1, this is cylinder 2, and this of course would be 3 and 4. So what we first want to do is see if it's an ignition coil problem. Just if it's an ignition coil problem, we're going to disconnect these 2 coils, and then we're going to remove the retaining bolts and we're going to swap them. So if the misfire tracks from cylinder 2 to cylinder 1, then that's a good quick way to diagnose if the if the ignition coil is what's causing the misfire. So to do that, we need to work these little gray retaining plugs out. You'll see it snap out from under this black here. I'll block you for a second, but then you can see it pops out. Just want to be super gentle on these so they don't break. And if they feel like they're stubborn, push them in a couple of times until it pops up like that. And then we should be able to squeeze the connector and get it to release. And what I'm squeezing is this black part. All right, and now with that undone, we're going to need a 10mm socket to loosen up the retaining bolt. I'm just going to set this up on the cowl, these bolts. All right, and then we just remove the coil from 1, remove the coil from 2, put number 2's coil on 1, put number 1's coil on 2, reattach the bolts. We won't worry about torquing this down for this test, we just want to get it snug. And then we'll reconnect the wiring harness, and we'll go back inside and restart the vehicle, and we'll look on the scan tool to see if anything changed in behavior. All right, we can leave the cover off, of course. All right, let's go back inside and see what changed. All right, let's restart the engine. And let's see what we see. All right, we are not seeing misfires anymore. So now let's go back on our data PIDs. Come on, touchscreen's kind of finicky on us. There we go. I hate these touchscreens. They get so temperamental. I'm just going to scroll down here and manually select the other cylinders. Just grab 3, I'm sorry, just grab 1. And we're just going to grab that one guy and see. All right, so cylinder 1 is now counting. So this very simple test, we've now identified that the problem is the ignition coil. So the ignition coil is what's causing this P030x code on this engine. Let's go ahead and get that swapped out so we can repair this problem, and I'll give you some tips from the service manual about other things you can check if it had not been this straightforward. All right, so now that we know what the problem is, let's go reverse what we did. These pop off. Let me see if I can do it like this where you guys can see. It's hard for me to get leverage like that. And then we'll take these 10 millimeters off one more time. And then this time, when we put the replacement in, we'll go ahead and torque this as well. And I'll show you some information from the Hyundai service manual for this particular engine that covers that. All right, so the one we put on cylinder 1 we know is the bad one. You can see here, if we zoom in, it's a genuine OEM part because we can see the Hyundai logo and the Kia logo. And it's a part number 27300-2E000. Now that part number may have changed or updated. When we go get the new one, we'll have to check that. But you always want to see if you're dealing with OEM parts. With ignition components, this one's also OEM. This is not a place to be going aftermarket. All right, so I'm going to set the old one up here while we wait and get a chance to replace it. But when we do the putting number 1 back, what you should always do on these is put a little bit of dielectric grease in the snout of the boot here. This is not for anything other than to prevent water intrusion on the spark plug. And before I pop it back on there, since our diagnosis is done because we didn't have to go any further, the next thing we would have looked at is the spark plug. It looks like right here when I'm trying to use the flashlight, the bulb's going out on it. I don't know if you guys can get down there and see, but all I'm trying to do here is make sure that, try not to have the light wash it out, that the tip of the spark plug is not corroded. If you do have water intrusion, these can get rusty, and if you're already here and it's rusty, it'd be a good chance to, or a good opportunity to replace it. So with that dielectric grease on there, we're going to put this guy back on and replace this bolt, and this time we're going to torque it down. The torque value, I'll show you in the service manual later on, but the torque value on this 10 millimeter fastener is 11.8 Newton meters. Works out to 8 and something change foot-pounds. All right, put this connector back on, latch it in, and now we need to wait for our replacement coil to arrive. Let me show you some information in the service manual while we wait. All right, the first page out of the manual I wanted to show you was just about the P030x, and Hyundai tends to add these trailing zeros on here, so they end up with a P030x200 is how they refer to it in the service manual. But just to show you some of the things that can cause this, right? So the very first thing we went for that can be a cause of this code is a faulty spark plug or a faulty ignition coil. The second thing they suggest is a valve timing issue. The third thing they suggest is uneven compression. Fourth is air leakage. Fifth would be improper fuel pressure or dirty or bad fuel. Six would be a blocked or leaking injector. And then last, they have leakage between the cooling system and the cylinder. This is a failed head gasket. In practice, with this particular 2.0 liter engine from Hyundai, if you scan the forums, what you'll find the most common causes for this misfire code is going to be either the spark plug or ignition coil like we had here, or it's going to be an issue with the fuel injector, or it's going to be an issue with the head gasket. Now, if it could always be any of these, but that's just the most common ones. And then over here, they're just talking about what the engine is monitoring for, or rather the computer is monitoring for to put that code up. I also captured this page from the manual. Here's the torque information. So 11.8 Newton meters works out to 8.7 foot-pounds. And then this test here I'm going to show you is, this is the only test for the ignition coil that Hyundai has in their service manual. It's a test of the resistance on the primary coil portion of the coil itself, right? There's test between the plus and minus coming in here. Some other manufacturers will do a test between the connector and the actual terminal that touches the spark plug. Hyundai doesn't have that, which would be a secondary coil test. So we're just showed this primary one, and what they're saying is that it should be 0.75 ohms plus or minus 15%. Now this particular test doesn't always find anything, but it's worth running. So we set our meter to measure resistance, and we come in here. It doesn't matter. It's not a polarity sensitive thing. You just find a way to get each terminal where it's going to be nice and snug. Get this where you guys can see it. See what we get here. So you give it a chance to do a reading, and it's reading 1.2 ohms or 1.1 ohms. It's kind of bouncing around a little bit, probably as the terminal and the probe make contact. A little bit of some glare there, so hopefully we can get past that for you. Move this meter just a hair. Yeah, so 1.2. So 15% means anything up to 1.6 ohms is probably okay. Now, this is a bad coil, and yet it passed that test. It's possible that this is only going to test for, you know, a cold room temperature failure. It's possible when it heats up that it is getting an open at that point, or it's possible that the circuitry inside is internally shorted, which this test isn't going to test for. All right, let's go ahead and wait for our new coil, and then we'll install it. All right, so we're going to be replacing this with a genuine Hyundai 27300 2E000 coil, so it's the same number as was originally used on the assembly line back in 2019 still. I highly recommend that you stick to OEM parts when doing electronic components on your engine, but even more so from Hyundai. So this particular 2.0 GDI engine has a form of extended warranty because of an internal engine problem. You don't want to have the Hyundai dealer have an excuse to avoid extended warranty like that by using inferior aftermarket parts. You want to stick to something that's OEM. If you're not under any kind of a warranty, you could then go, in my opinion, with something that's a top-tier OEM supplier. But when you're still under some kind of warranty like that, you want to stick to the genuine article. So if we zoom in here, we can see it's clearly logoed as Hyundai Kia, and it's the same number as what we pulled off before. So the only other thing I'm going to do is the same kind of inspection we did previously, just peeking down the hole here on the bore, making sure that our spark plug is not corroded at the tip. And I guess you guys can come and take a look as well. Get you guys down here and zoom in there, and it's nice and clean. That's what we want to see. Grab our dielectric. Now, is it possible to have a bad coil right out of the box? Sure. Even with an OEM part, it is possible. We'll run a quick test here. We don't want to get the old one confused with the new one. Set that over there. Same test we just did previously. I don't expect there to be any problem here, but why not? And this guy is showing basically the same thing. So I'm mostly showing this test just to show you that relying on simple tests like that alone is not sufficient for judging whether the part is defective. Sometimes it's worthwhile, that's why the OEM includes the test, but not always. I'm realizing here that we probably should not have connected this number 1 because it's going to get in our way to torque this guy down. So let me pop him back off again. Go ahead and grab our torque wrench, torque him back down, and then we'll go back inside the vehicle and verify the repair. All right, now we're good. We can go ahead and take a quick inspection of the others because we're all down here, make sure that everything is properly installed, and we can also just double check to make sure these other ones are torqued down. Since we're here, we're all good to go. Let's go back inside the vehicle and verify the repair. All right, guys, and since we're pretty confident of this repair, we're just going to go ahead and reinstall our cover. And go back inside now and test it. All right, guys, we're just going to select all of these Misfire PIDs. Let's go ahead and restart the engine. Check engine light is still currently on. But I'm not seeing any misfires, which is great. Now we know we had kind of like a software glitch where this particular level of the launch software wasn't recording anything on these particular PIDs anyway. So if I go back over here, I can go ahead and exclude those because they don't show up anyway. Just to make sure we get the ones that should show something, and we're not getting anything. So we fixed this problem. So what about the check engine light? We flip up to the dash here, right? The check engine light is still on. Are you going to clear the code? Well, no, I don't usually clear the code. What I like to do is I like to let the ECU clear the code itself. So what should happen is if we've got this fixed, that light should go out after a couple of drive cycles. The engine will see that I'm not seeing it's not seeing any more misfires, and it'll go ahead and turn that off. So I'm going to leave that on as confirmation of the repair. Why didn't we change all of the ignition coils? Well, it's true that when one goes, the other three are probably not far behind it. But we're going with OEM parts to protect our extended warranty eligibility, and that's kind of pricey. So my advice is replace them as they fail in that situation. If you were not in that kind of situation, then you might elect to proactively take out the other three because they're all manufactured at the same time, so they're all going to eventually fail within months of each other. But at this point, this one's fixed. We can push this car out of here, give it back to the owner. We can have them confirm to us that the check engine light went out, and they should be good to go. If you got questions or comments about this particular repair approach, go ahead and leave them below. If this helps save you some money on doing this job yourself, I'd appreciate you paying it forward by hitting that like button. And as always, thanks for watching.